Hi, good morning. I am Dr.D.Sathya, Working Assistant Professor, Department of Chemistry, SNS College of Engineering. Today, we are going to discuss about instrumental method of analysis. Analytical instrumentation plays an important role in the production and evaluation of new products. So, the different types of analytical instrumental methods have been find use of variety of industries. So, these include molecular spectroscopic method, thermal analysis and X-ray diffraction, electron microscope and sensors. So in the different instrumental analysis, first we'll discuss about UV visible spectroscopy. In UV visible, what is meant by spectroscopy? So spectroscopy is a branch of science which deals with the study of interaction of EMR with matter. EMR means electromagnetic radiation. When the substance is irradiated with electromagnetic radiation, the energy of incident photons may be transferred to atoms and molecules, raising their energy from ground state level to excited state. So this process is known as absorption and the resultant spectrum is known as absorption spectrum. So it's one of the powerful tool available for the study of atomic and molecular structures. So the energy changes that occur in atoms and molecules during the interaction with the different regions of electromagnetic radiations are given in this picture. So the most of the radiation surroundings cannot be seen, but some we can detect it by using some sensing instruments. So this electromagnetic spectrum ranges from very short wavelength including gamma ray, x-rays. It's a very long wavelength like microwaves and broadcast radio waves. So this picture displays the many of important region of the spectrum and demonstrates the inverse relationship between wavelength and frequency. Here, the wavelength is defined as the distance between the adjacent peaks and may be denoted in meters, centimeters and nanometers. Frequency is the number of wave cycles that travels fast the fixed point per unit time. That means within the second, it's passed the travel to the fixed point. So, it's usually given in a cycles per second or hertz. So the visible wavelength cover the range from 400 to 800. The longest visible wavelength is red and the shortest range is violet. So what is ultraviolet spectroscopy? The ultraviolet spectroscopy is used to obtain absorptions of spectra of compound in solution or a solid. So the absorptions of light energy or electromagnetic radiation which excited the electron from the ground state to first singlet excited state of the compound. It's a qualitative, quantitative and analytical technique that comparisons of the sample with the blank or reference sample to measure the amount of discrete ultraviolet and visible light absorbed or transmitted through the particular sample using Beer-Lambert's law. So the principle of the electronic transition and the instrument required to record the electronic transition is a common for both the regions. Here the wavelength of UV visible spectroscopy, already we discussed about the wavelength 119 to 800 nanometer. The UV region represented 200 to nanometer and 200 to 400 nanometer and the visible region is 400 to 800. Near UV region is 200 to 400 and far UV region below 200. The very starter with the wavelength is higher will be the frequency and energy. It occurs in UV region. Similarly, the higher the wavelength, the lower the frequency and the energy in the visible region. The principle, when the specific wavelength of light hits a molecule, that the molecule get excited. So once the electron excites from the ground state to higher state. When the electron jumps off, it absorbs the light energy because the electrons in the orbital at the lower energy state utilize the energy to move on the next level. So the energy is neither created nor destroyed but can transform energy from one form to another. So on the passing EMR, electromagnetic radiation, only the light possessing the precious amount of energy that can cause the transition from one level to another level. We'll observe because its a matter energy level is quantized. So the Beer-Lambert's law. When a beam of light allows to pass through the transparent medium, the rate at which the intensity decreases with the medium thickness. It's directly proportional to the light beam. Beer-Lambert's law is especially useful for obtaining concentration of the substance if the linear relationship exists using some measured set of standard solution containing the same substance. So according to the Beer-Lambert's law, the absorbencies in the concentration is directly proportionality. So here absorbance is equal to ECl. E for molar absorptivity of the compound or molecule solution. L is optical path length. A is the absorbance. C for the concentration. So thank you to all.